Okay, so I will share my screen now. Okay, so convolution, the term is actually xn into hn. So mathematically it is represented by star. This is the multiplication. Actually, the convolution is a process when any signal is passed through a system. Suppose xn is passed through a system hn, then output yn is related to xn by yn equal to xn convolved with hn. So it is a process. If any signal passes through any system or any filter, for example, filter is also a system. So when it passes through a filter, then output is yn, and output is equal to xn into hn, where hn is the impulse response of the filter. Okay, so xk and hnk, the convolution is given by this summation from minus infinite to infinite, and xk and h of n minus k. For example, here there is one sequence given, which is one sequence is shown here. So this is h of n, for example, and if this one, suppose this is x of n, this is h of n, then convolution looks like this: x of m. X of m is represented the convolution sum, the result of convolution, for example. So
sir can explain us where all we are using convolution. We didn't, some places you mentioned, but you can tell us in general where we use convolution.
Yes, actually convolution is used in almost all LTI systems. So wherever there is, whenever we know a input of a system, see all the digital system, all filters use convolution. For example, I am giving example of filters. So filters use convolution. You have x of n input and then y of n output. Then there is in between filter. So yn will be equal to input convolved with filter. Okay, so and this filter is designated by its impulse response h of n. Therefore, this x of n convolution with h of n will be the output of the filter. So that is why I am discussing here, because this is important for filters also. Okay, so that is the one application. You can understand for filtering is one important application, and filters have many applications in practical life. So you can understand that convolution is part of filtering. Whenever we need filtering, then we should know the convolution operation. Okay, the process of convolution is that if you there is here, if you see this convolution sum, one input is xk, another input is hk. So h of n minus k means this h of n. H of n is actually k is the variable, so h of minus k. So first of all, we need to have representation of x of n, then h of n. First of all, we need to represent xn. We need xn, then or here we can say x of k, because convolution is done x of k. Then we need h of k, then h of n minus k. Then we are multiplying h of k with h of n minus k from minus infinite to infinite by moving these, because this is a constant and this is variable k. So we are changing from k from minus infinite to infinite, multiplying these two, then the result, adding all the results. So this is the process of convolution. Okay, so I will show it graphically also here. Graphically also it is given below. Let us go down. Here is one example of convolution that I have H of k as 312 and H of k as 321. Okay, and both are starting at 0th position, so there is no problem of starting. Okay, so here we can say that first of all we have to write k. So we will take k from length h minus 1. So length of h is 3 minus 1 is minus 2. So we will start from minus 2 minus 1 like that, or end of k will be the length of x of k is 3, length of h of k is 3. Okay, so here you can say minus 1, so end of k will be 5. So these are the two values. This is the index value. Up from minus 2 to 5 we will take index. First of all I am deciding index values. So the starting value will be length of h is this one, length of h 3 minus 1 minus of that, so that is minus 2 to 5, and 5 is length of h and length of x minus 1. So 3 plus 3 minus 1, 5. So we will go from minus 2 to 5. This is the range from minus 2 to 5. This is one index, anyway you have to take any index. So you can take minus 5 to 5, no problem. But this is the recommended one, that we should take minus 2 to 5. Then I am representing the value of xk. Xk value is 3, 1, 2. So 0, at 0 the value is 3, at 1 value is 1, at 2 value is 2. And hk is not written. Hk is 1, h of minus k is 1, 2, 3. Hk was 3 to 1. So h of minus k will be 1 to 3. So h of minus k is 1 to 3. Location. See, h of minus location of h of minus k will be. You can see. I will show you like this. See, the h of k is from here. The value is 1 at 0. Value is 2 at 1. 0, 1, 2. And value is 3 at 2. H of minus k is the mirror image of this. So the value at 0 will be 3. See this, at 0 the value is okay, so this is 3, this is 2, this is 1. So here it was sorry, actually I have written just opposite. It was not like this. It was not like this. H of k was 3 to 1. So at 0 the value is 3. At 1 the value is 2, and at 2 the value is 1. So this is actually the so minus 1, minus 2, minus 3 is 0, and 1, 2, 3 is also 0. All other values are 0. At 0 value is h of k. I am plotting h of k. Okay, so h of minus k will be just a mirror image of this. So 0 value will remain at 0, and at minus 1 we will get 2. 0 value is 3. At minus 2 you will get 1, and minus 3 is 0 again. Here 0. So that is what we got here, h of k. That at minus 2 we have 1. Okay, at minus 1 we have 2. At 0 we have 3, and all other values are 0. That is what is happening here. We are taking mirror image of the h of minus k. So I think these things are known to the person who are doing signal processing. Then I am shifting this by 1, right side by 1, and then you have to multiply it with this one. This the xk into h of minus k is also to be multiplied. See, only these two values can be multiplied. So here the multiplication will be 9. So first result will be 9. Then I have shifted it to the right. You can see 0 is here, 1 from here came to this point, 2 from here came to this point, and 3 from here came to this point. Shift 1 right, and then multiply this with this x of k. So if you multiply this with x of k, so here 0, so the multiplication with 0 is 0, 0 and 1. So multiplication with 0 and 1 is 0. 2 multiplication of 3 and 2 will be 6, and 1 and 3 will be 3. So 6 plus 3. You have to then add. If there are more than one results, then these results together. So again here is also 9. Okay. This way we have first result 9 and second result is also 9. Okay. Don't know what happened. Go down. Similarly, we can continue the process and save this result like this only. So I have just shifted it again and again when all becomes 0. This is how the table looks like. This is the complete table. Okay, then we have to do, so the process is written here 3 into 3 9, and like 3 into 3 like that. So when there is no overlap, then 0, and before this also there was all 0. Then we can plot this. So the plot of this is the result. This is the result of this 9 9 11 5 to 0. Okay, so this same thing we have to do in the MATLAB. So then we have to first of all take the values. We take by input command. Then we have to take the 0 value of x, 0 value of y, h, and then take input of h, like that only. So the same the inversion value of k starting and ending. Then this time inverting this by in this loop. I'm just inverting that, and then we are doing this some changes, shifting, like that only. So this process you can see, and I will share this document so that everyone can see, and I will share the code also so that you can go and I'm just sharing code with you so that you can also try this convolution step by step. Okay, so here is the code of convolution by step, my convolution .m. So I'm just sharing it with you. You can try this code. I think some part is so there is some limit in this, so that some part is not there. So for okay, so I'll share in Google Classroom. Then from there you can see. You can I just now you just see the results, and then later on you can practice for this. Just enter the values of xn. See our values in this example. The values of xn are, what are the value? X of n, x of k is xn. So 3 1 2. So values are 3 1 2, and the starting position is 1. The values of h of n are 3 to 1. So 3 2 1, starting with 1 only. So 9 9 11 5 to 0. This is the result here. That convolution sum is 9 9 11 5 to 0. And so that here what was the result? You see, this was also 9 9 11 5 to 0. So same value is coming. That means this program is working correctly. For you can check for other values also. Okay, so this was the basic idea. How can we do the convolution process, and how can we can get output. Now the main purpose is to discuss is filter design. So filter design In last session, I was discussing filter design by windowing, filter design by some other methods also. So you may find that I am not going to go in details, and I would not like to program. So MATLAB provides filter design app in itself. So to open that filter design app, in old version, the command was FDA tool, FDA filter design and analysis tool. Okay, so if you are using an older version of MATLAB, then you can try this FDA tool. Try this command. Write FDA tool in command window, and then you will this will open. In newer version also it will work, and also it will give a warning that it will be removed in future. See, in my MATLAB, it is showing a warning that FDA tool will be removed in future. The new name for this same tool is filter designer. The new name for the same tool is filter designer. So if I close this toolbox now, filter design tool, and this app now, and if I type this filter designer in my command window, this command, this will also open the same this filter designer app. But if you use this filter designer command in the older version, it will not work, but it will work in newer version only. So both FDA tool and filter designer app are same. So any of the command can be used. Okay, so after you use when you are using first time, it will show the some tips of the day, like that thing. So if you want to read, you can read. Otherwise, you can click here that do not show me again. If you are well versed with this filter designer app, then you can say that I don't want to use it. Okay, so this app is now open. Now I will tell the windows available in this app. See, first of all, let us understand that what all things are there in this app. You are seeing this main filter specifications here. So you should understand the filter specifications first. That this part is actually passband of the filter. If you design a filter, so then it shows some ripples. So the ripples in the passband, this is the attenuation A pass. It is representing this ripples, that what are the ripples in the passband. Then filter goes to the stop band, and in the stop band also many times ripples are there and many times ripples are not there. It depends on the type of design. So here they have given only specifications in dB. So this is in dB, and this is a stop band attenuation. Passband ripples are also represented in the dB, and stop band attenuation, this is stop band attenuation, this is also in dB only. Okay, and see this one is transition width. This is the transition from here the filter is going down, and here filter is reaching to the stop band. So this is the pass band of the filter, and this is stop band of the filter, and this frequency is pass band cutoff frequency FP, and this is stop band cutoff frequency FS. Okay, so this FP and FS are important in the digital filter design, and also the ripples, what kind of ripples you want in the filter design. So that ripples are also important. Okay, so this is how this works. See here, the point is the up to, we are going with sampling frequency by 2. This is important to understand. This also I told in the previous session that we can design filter up to FS by 2 only. For example, if you have sampling frequency 1000 Hertz, then maximum range of filter can be 500 Hertz. So then you can design, for example, if you are designing the half band cutoff frequency, then this cutoff frequency should be 250 hertz. So I will say pass band cutoff frequency can be 200 hertz and stop band cutoff frequency can be 300 hertz, and in between 250 hertz will come as a cutoff frequency, like that. Pass band attenuation can be 1 dB and it can be 80 dB, 40 dB, up depends on the requirement. Stop band attenuation. Okay, so these are the specifications of filter. Those who have designed already have gone through the DSP, they can understand it well. Okay, so I hope this is clear. And in this there are some there are some other tabs also. So the first one is to see the magnitude. This is the actually some filter, and this is actually a magnitude response. If you want to see the magnitude response of the filter, you can click here. If you want to see the phase response of the filter, then you can click here. If you want to see the magnitude and phase both together, then you can click here. And this one is group delay response of the filter, and this is the phase delay, and this is impulse response. This is step response. Step, you can see this is pole zero plot of the filter. You can here if you click here, you can see the coefficient of the filter. This is filter information about the filter, that which kind of filter is that. So filter information, and this one is again the magnitude response, and this is the noise analysis. This is how a lot of analysis tabs are available in this filter designer app. See, you can see this thing. Just you can see this analysis kind of thing. So I will take one example of filter. I'm going to design a filter of specification. Let us take some. Okay, I will take one example. Before that, I just go through this. What are the facilities available in this? You can change the response type here. You can design low pass, raised cosine, inverse cosine, sync type of filters, and you can design high pass filter, half band filter, like that. You can design band pass filter also. If you want to design, you can design band stop filter, differentiator, Butterworth, IIR, FIR can be selected from here. Here you can select that if you want to use IIR or you want to use FIR. You can specify your order if you want. Otherwise, MATLAB will decide order. If you select minimum order, then MATLAB will decide order, that what should be the order. Order of the filter is actually the polynomial. For example, the filter h of z will be 1 plus a0 z inverse plus a1 z to the power minus 2 a2. If your these a are actually filter coefficient, and order of the filter is the order of this polynomial, z polynomial. So if number of coefficients starts from this point only, a0, a1, a2, a3. So you can see that the number of coefficients are one more than the order. So if order is 10, for example, then number of coefficients will be one more than that, 11 coefficient. If you take order equal to 20 order filter, if you design, then coefficients will be how many? 21. One more than that. Why one more than that is coming? Because of this kind of polynomial is there in the z response of the filter. So that is why. Okay. So that is why I'm saying that what will be the order? Order will be one less than the filter one less than the number of filter coefficient. You can specify filter order here. If you take here, then by yourself. Otherwise, it will take minimum order automatically. And also you can specify here the sampling frequency, pass band cutoff frequency, stop band cutoff frequency, pass band attenuation, and stop band attenuation. These are the filter specifications that we can assign. Okay, so here I am going to design one filter, and I will show you how that filter works. So let us take one design of FIR filter. So if design, suppose a problem is that design a FIR filter, design a FIR filter with f of s equal to for example p, passband cutoff frequency 200 hertz, stop band cutoff frequency 300 hertz, okay, and sampling frequency as 1000 hertz. Okay, then this thing we can take passband attenuation AS, stop band attenuation 80 dB. Okay, these are the specifications given to me, that design a FIR filter with these specifications. Am I audible to all of you?
Yes, sir, you are audible.
Any question till now? Any question?
No, sir, no question, chat box.
Okay. Are you able to get this filter designer app in your MATLAB? Are you able to open this filter designer app? Okay.
Yes, sir, there is a response, yes.
Anyone else? Ritika is saying yes. Or anyone else? You can just type FDA tool in command window. You will open. It will open. And I am going to design a FIR filter. So I have to select FIR here. Low pass filter, FIR low pass. Of course, it will. If I'm taking passband cutoff frequency 200, so we are designing a low pass filter only. Design a FIR low pass. Okay, so so low pass is here. Low pass should be selected, and FIR is selected. Specify the order. So you can take minimum order according to your specification. It will decide. MATLAB will decide that what is the minimum order required. So I will design with both. So first of all, I will specify the order that I want to design with 20 order. Okay, so just I have taken some order, and I have to write 1000 hertz because the specification is of 1000, and passband cutoff frequency is of 200 hertz, stop band cutoff frequency is of 300 hertz. Okay, then let us design the filter. All the things are okay. Design the filter. See, this is the design. So this is the design. Design is ready. Now I will go to these analysis that I was telling, that I can see this is the magnitude response. You can see that in y-axis magnitude is visible, in x-axis frequency is available. So this is the magnitude response. If you click on this is phase response. You can see because I have designed the FIR filter. So the phase is linear. You can see in the pass band the phase is completely linear. In the stop band the phase is varying. So we're not varying. In fact, it is linear, but it is a stepwise linear. Okay. Next this is the magnitude and phase response both together. You can see here group delay is constant in FIR filter. So you can see that constant 10 in here. In this case, the group delay is 10. Okay. So you can see this group delay and phase delay. Phase delay is 0 almost. There is no phase delay problem, and so this is almost 0, but it is a little bit higher than. So this is phase delay. This is magnitude response of this filter. Yeah, sorry, impulse response of the filter, and this is step response of the filter, and this is the pole zero plot. See here, they are all here. This is the all 20 are together, all are zeros. There are no poles. You can click here and you can see the coefficient values. You can see all are in the numerator only. If you could have designed the IIR filter, then there will be some numerators and some denominators also. And by default, you can see that the last value and first value is same. If you observe the first value of this coefficient, so and last value is same. So this is a type 1 kind of symmetry. If you have gone through this FIR, there are type 1, type 2, type 3, type 4. There are 4 kind of symmetry in the filter design. So this is type 1 symmetry available in this design. Okay. So you can see the coefficient, all values in detail, long type here you can see. After that, the filter info. If you click on this I button, this is a filter info. So you can see that this is a direct form of FIR filter. Filter length is 21. That means the length, the total number of coefficient in this filter are 21, and the total number of linear phase, yes, implementation cost, number of multipliers, these many adders, these many states, these all things you can see here. And there is a noise analysis also. If you apply noise, then what noise will work in this. So this is a noise kind of analysis in the filter. Okay, so these are different responses of the filter. Now, how can we use it? Actually, we design filter for using anyway. So the how can we use it? That is the requirement. That how can we transfer it to the workspace? Can I transfer to the program that I was using in the last session? Can I transfer this the value of H from this design to the program? Yes, we can transfer the value of this design filter to MATLAB workspace. So if somehow if I can get the value here in the workspace from the filter designer, then I can use it in my any waveform that I have generated in the program, or if any waveform if I have in the workspace. So how to do
Sorry
that?
sir.
Yes.
Sir, there is a relative question that a question by Ankul.
Okay.
What are the applications where we use this filter?
Low pass filter is used for passing the low frequency component and suppressing high frequency component. In communication systems, filters are used. Low pass filters are used in demodulation. Also, low pass filters are must in the demodulators. So transmitters, receivers, they use noise suppression for removing the noise from the signal, high frequency noise from the signal. Then we need this filter. So that is the requirement of filter. And if there is a signal which have two frequency component, so if you want to separate those frequency components, if you want to keep a low frequency component and if you want to discard the high frequency component of that particular signal, then also we can use this low pass filter. So these are the applications of low pass filter. Anyway, so let us transfer this filter to workspace. So I'm showing one application now. Just wait for some time. I'm just showing one application. So here in file menu, there are many things. You can save this filter. You can export the filter to the workspace. You can export the filter to Simulink model. You can export the filter coefficient. You can import the filter coefficient. There is exporting also to Xilinx coefficient, the VHDL coefficient file. Then you can generate a MATLAB code for as a function, MATLAB code function for this particular filter also. Okay, so currently our purpose is just to export to workspace. So I will click on export and then export to workspace. And I usually take coefficient and the variable name for coefficient h of n, because and then override the variable if there is already in the workspace, and then click on export. Just so variables, you can see the information that variables have been exported to the workspace. You can see here the information that the thing that we were trying to transfer the filter to workspace. So this is exported to the workspace. What will be the name? Name will be H. Let us go to the workspace and see whether this is available in the workspace or not. I'm going to workspace. See this filter of 21 length is available in the workspace. That is what we were intended. We were trying to do that. Our filter should come into the workspace. Now I will generate a signal. I will apply the filter to that and get the output to it. Okay. So before going to that, I would like to take questions if there are any questions.
Yes, sir. There is a question by Dr. Suresh, sir, that how to upload the time domain signal, that is Excel data or text data, for reducing noise or filter the signal.
Yes, Suresh sir. If you will have the signal in Excel data, in Excel file, then you can refer to the previous session. In the previous session, I had data test data dot XLS file. So in that file also data is in the Excel, and the program that I was using last time I had given shown the many things based on the filter feature extraction of the fields. So feature extraction, for feature extraction we are importing signal to the MATLAB. See, if you have data in Excel, you can use program like read table. This read table command, this will take your data into the MATLAB workspace. So your data will also come here. So if your data is available in the workspace, filter is available in the workspace, output, you can apply the filter to this data. Your output after applying the filter will also come in the workspace. That you can save again to Excel file, and you will get the noise reduction in the signal. So that is the way to read the data from Excel. And so I had done this thing many times in the previous session. I was reading the Excel data only from test-data.xls. See, this was the data in Excel file. I was reading it. So if you can read the data in the same way for filtering also. So for filter design also we can use for data in the same way, and the design, you can design filter in the filter design tool, and you can export then let it come to your workspace. And then for example, I'm just generating the data. I will show you FDA Tool filter, this program. I don't know. Okay, so here I'm generating data into the MATLAB itself, but no problem. I can take data from Excel sheet. No, that is also possible. Okay, so just to show the exact representation, I am just generating the data. So here the filter was different. Actually, they want the filter to have pass band cut off 100 Hz, stop band cut off 200 Hz. So okay, so I will change it later on to this. Currently, I am applying the same filter. Okay, so for that, first thing is to generate the signal. So I am generating one signal. This is the signal, digital discrete signal, which have two frequencies. One frequency is 250 Hz. Another frequency is at I think 0.25 of 500 of 125 Hz. Actually, this 0.25 means that this will be of 1000 Hz. If 1000 Hz is sampling frequency, then it will be 500 will be working for the filter, half of the sampling frequency. Then if you are taking 0.25, that means 500 into 0.25, so that is 125 Hz. Okay, so 125 hertz 1, and another I am taking at 0.7. So this will be 500 into 0.7. So this will be 350 hertz. So okay, so this is the two frequencies that are mixed together. I've just mixed those two frequencies. One frequency of 125 hertz. So I'm mixing two signals purposely. One signal of 125 hertz. 125 hertz means 0.25, and another signal of 350 hertz. Okay. So let us mix these two. I will just show it like this, so it will be more visibility will be more, so you can see. I will just increase the font. You can see this. Okay, so you can write this code. This is I'm generating signal of mixed frequencies, so I'm just commenting it. I don't want to see it now. Now generate a filter by FDA tool. See, the H variable is not available. So if you write this, if you perform this operation without generating a filter from FDA tool, this will not work. This will show error. And currently I have generated it, so it will not show any error. See, here I am not writing clear in the starting. In general, I write clear in the program, but here I am not writing. The reason is that if I write clear, then my filter will also get clear that I have generated from the FDA tool. Okay, and now after generating the FDA tool, you can apply this filter. The command for filter is, see, these are the filter coefficients that were available in H. Then the denominator part is 1. See, this filter, this is a general command for filter. Okay, I can use convolution also, convolution of X and H. So convolution command can also be used, but filter is available for this kind of design also, that have B by A. So B0 plus B1 Z inverse plus and so on, divided by A0 plus A1 Z inverse, like that. So this is the H of Z of IIR filters. So this filter command works for both FIR and IIR. So in FIR, they take denominator as 1, because in FIR only numerator is available, denominator is not available. Okay, so therefore I am taking 1 here, and X is input that we have generated earlier. X is actually this input that we have generated. Then Y will be the output. Okay, so Y is the output. Okay, so that is here. You can see Y is the output, X is the input. So this way we can see. Now I am just doing some changes just to show it in the normalized frequency. Just I am changing, because 2 pi and taking the FFT just to represent the frequency component. To show you the frequency component, I am taking the converting it in the frequency domain and representing it. Now you can see this was the original signal which have 2 frequency component, and this is the filtered signal which has only 1 frequency component. You can see that plotting I have done here. I have plotted Y, half of Y bar, because the FFT is 2-sided, so I have plotted half of that, and this is the original signal, the frequency response. This is in the frequency domain, original signal which have 2 frequency component. One was here and one is here. So at two places, and you can see that only one is coming in the output. Okay, so this filter is working. The whatever filter I have designed, this filter is actually working. And if you are doing this, I will share the code in this code also, so that you can also analyze. Instead of this, Suresh sir, instead of this signal, you have to take your signal. Here you have to write code for reading data from Excel. You have to delete this, and then you have to write code for reading data from Excel, and your signal will come here in the X. Save it in the X. The remaining part can be same. Then that is, you can do things. You can see this thing, and the response and all thing. For seeing the response, there is a command that you freakjet. If you want to see the response of this H, then this command is to see the magnitude response of H. So it will show. See this is the magnitude response that was there in the FDA tool. So same response can be seen in the program also. Here I am using this thing. This is the phase response. So we can see that this is the filter what we designed. Anyway, let us come back to our FDA tool. I need to tell you many other things also. Okay, so there are many things in this FDA tool. We can design multi-rate filters. How to design multi-rate filter? You just have to click here. This is for multi-rate. This tab. There are tabs here also, and in this FDA tool there are 6 tabs here also. These 6 tabs are also very important. First one is for multi-rate. Multi-rate means you can design the differentiator, integrator, and interpolator, etc. Decimator. And the second tab is for filter transform. You can transform a low pass filter to high pass filter. So this second tab is transform tab. Third tab is quantization tab. So here you can do quantization. Quantization means generally in the MATLAB filters are designed in double data type, but many times Xilinx and FPGAs, they do not support the floating point double or floating point data type. So you need to convert it into the fixed type of point data, fixed type of coefficient. That can be done in this tab only. And fourth tab, this tab is the implementation model, direct from 1, direct from 2, like that. So that is model or implementation architecture, you can say. So which kind of architecture it will use for implementation, that is here in this tab. And next one is pole 0 editor. You can add poles, you can delete poles. So pole 0 editor is here. And this tab is import filter from workspace. You can go import filter from the file also. Here this tab is added. This will not be available in the earlier version of FDATool. So this is available only in the newer version. And last one is filter design, which we are seeing currently. The window that which is selected, which I have selected currently. Okay, so I will go to it one by one. If I click here, you can see interpolator, decimator, like that. Okay, and here you can transform low pass to high pass, and here you can select it, that which kind of single precision floating point, fixed point, and which kind of filter arithmetic should be used. Yeah, you can use double precision floating point, single precision floating point, etc. Okay, and here you can see this is the implementation. So which kind of implementation you want, for zero gain, for like that. So this you can see the implementation model. So if you want to realize the model, click on the realize model. It will I think prepare the model for this particular filter. Because I have clicked on the realize model, it is realizing the model. It is converting it to the model. I don't know how much time it will take to implement, because it was of 20 order filter. So 21 different branches will be there in this implementation of this. So see, Simulink is open, and this is see here, this is the filter available in the Simulink. So you just connect input here and connect the output here, and then you can use this as a model. just connect the input block and the output block like that. So if you double click on this, I think it should show that parameters coefficient values are here. Anyway, I'm not going to show this Simulink block, how to use that is here. But anyone who knows Simulink, who is expert in Simulink, he can use the filter as a block also. This is the pole zero plot of filter that we had designed. So I had already shown that there are, so you can add or delete the poles and zeros here. Okay, so I'm not going to that also. So filter direct form 2. Okay, so these are the numerator coefficient, these are the denominator coefficients. Anyway, this is the filter structure to import filters from the. Anyway, so these are the different options here, and how to transfer to HDL. I was telling that how to generate HDL. You can generate MATLAB code for this filter. Just click on the function, then this will saving is this as MATLAB function. For example, I will save my filter fun means function. So you can see that my filter function is created. So equivalent code of this filter can be function as a function can be created from in this filter designer app. Okay, so and the targets, in the targets there you can generate C program also, C header, the header file that can be used in the C programming. We can generate from here. We can generate Jaling's coefficient also, but I don't have the some particular one in the new the license for this generating the HDL code. In your, if you are using the crack version or something like that, some other version of MATLAB, the previous version of MATLAB, because I am using the licensed version, in which I have not taken the license of this fixed point, therefore it is not working. In your it will work. If you can check it, if you click on the target and click here Jaling's file. So in this target only, in the earlier version of FDA tool, there was generate VHDL code, generate C header. There was generate VHDL header like that. That also, that kind of option was also available. So those who want to get the VHDL equivalent code of this, you have to go to the target, click on the target, and there is option. So in this this version, this is not available. In my MATLAB, that subscription on the license for that is not available. Therefore, it is not generating the Jaling's code. But if in your MATLAB or in your FDA tool, if the license is there, it will generate. And then before generating, you just keep this in the fixed point, because most of the FPGAs support fixed point. Just convert it into the fixed point, then you generate. It will be synthesizable in the Jaling's ISC. In the Jaling's or Vivado, you can synthesize the code generated from here. I cannot demonstrate because the license is not there. Otherwise, you just you try, it will work. Keep this fixed point, generate it from here. This will work. Okay. But today I cannot demonstrate because here it's not available. Anyway, so this was the basic analysis. If you don't want to click here, you can do analysis from here also. You can click on particular. If you want to see filter coefficient, it will show you filter coefficient. Okay. So you can go to the filter manager also, and if you want to add it and cascade and do something changes, so here there are some options. Okay. This was the filter designer app. One more thing I need to discuss with you today is that that is the filtering in the two-dimensional in the images. So this was the discussion of one-dimensional filters. Now I will go to the two-dimensional filter, that is image filters. Okay. So now we are going to discuss new topic, that is 2D filters. 2D filters are used in the image, so image filters. Okay, so as I told that the filtering works on convolution. So in 2-dimensional there will be 2D convolution. As in 1 dimension we had 1D convolution, and in 2 dimension there will be 2D convolution, isn't it? How does it work? What is the 2D convolution? I will show you with one example that is given here. These kind of operations called neighborhood operations, because they affect the nearby pixels also. So therefore these are the neighborhood operations. The equation for 2D convolution is this. The previous equation was 1-dimensional. Only one summation was there, from minus infinity to infinity for k, x of k, h of n minus k, like that. Because the convolution is 2D, so there are two k, one k1, another k2, k1 minus infinite to infinite, k2 minus infinite to infinite, x of k1, k2. X is also 2-dimensional and h is also 2-dimensional. In MATLAB, here you don't have to do all the step-by-step coding of 2D convolution. You can write a command conv x comma h. Okay. However, this this command is of signal processing toolbox. Therefore, you need to convert images into the double data type before performing convolution operation. That is important to note. Okay, so I think okay. So that is no, sorry. So here you can see this. This is what convolution is. One example is here. I have A. A is a matrix. You can see 17, 24, and 1, 8, 15. So what is the size of this matrix A? What is the size of matrix A? If I store it into the MATLAB, and then what will be the size of matrix A? And what is the original size of matrix A? Image is a matrix. We know that. Image is actually a matrix. So that is why I have taken one example of matrix. Yes, it's of 5 cross 5 size, and H is of the filter is of 3 cross 3 size. So it is not necessary that the size of filter and the size of image should be same. It can be different also, and we can take same also. We can take same different also. There is no there is no requirement of that. Both should be same. What will happen here in the normal 1D? This was initially mirrored, then it was overlapped, then it is moved from minus infinite to infinite, then multiplied, and the summation was saved. So in the 2D, what will happen? Initially, the second one, the H, the filter will be rotated 180 degree about its center element. How this rotation work? You can see the result of this 816 and 3, 5, 7 and 492 will be converted to this like this 294, 753, like that. See 294. Okay, 294. See what happened. You I think you are able to understand what is happening. What is happening here? The original matrix was 8, 1, 6, 3, 5, 7, 4, 9, 2. Now it is starting from here 2, then 9, then 4, then 7, then 5, then 3, like this. So this is the rotation in the 2D in the matrix. This is how it's rotated. Means negative of this matrix is calculated. Okay, h of minus k. This is h of minus k. And what will be the shifting? So first value is calculated on h of minus k itself. So you can see that when it is overlapped with this particular big matrix, that was x of k. This is x of k, and this is h of this is x of k1 k2 because this is 2-dimensional, and this is h of k1 k2. So when it is moved over this particular image, and for example, if it is placed over this place, this will move over in the overall horizontally and vertically both, and at every place the resultant will be calculated. So for example, if it is available here, and then the overlapping result will be like this: 1 into 2, 8, this 1 into 2, 8 into 9, like this, 15 into 4. So this multiplication and the result. So that is what is convolution is. So one result will be 575. Okay, like that. So this is what is done in convolution. Just for your understanding of 2D convolution, that how does 2D convolution works. So here I am taking one example. I am reading one of my image and converting it into grayscale, and then here I am writing this double C double H for converting it into double. Okay, because I have to this convolution command will work on the double only. Then I am seeing it again. Again I am applying the same convolution to convolution 2 with I can apply convolution, or I can apply filter also. So those will work same thing. So double of h dash. So first here I am taking h, and again I am taking h dash, and then I am seeing it. So I will show that how this filter work. This filter have amazing this 1 to 1 0 0 0 minus 1 minus 2 minus 1. This is one filter, 2D filter. Okay, so let me show you that how does this work. What result it shows. We need to go to I like to save it here only. This is one. This is the program. This I can convert it separately also, and I can write in the same command inside the command also. There is no but just I will comment it first. These three I have just commented these three. I just want to see the filtering. This is the result of filter. H is the result of filter. So what does it give? See, this is the result. How was the original image? You can see original image. You will say that, sir, what you have done, instead of improving the quality by filter, this filter is decreasing the quality. This was the original image, and this is the filtered image. So it's not always that we perform filtering for removing the noise. Many times filtering is performed for other purposes also. So here I can see some horizontal kind of lines are there. Then I am using the H dash of this for vertical lines. You see that second figure window, figure 4, it have some vertical lines, and the first figure window that have some horizontal lines. Oh, sorry. This was this. This is third figure. This is the first figure window. No, Let me first write CLC clear and close all. This works for me. Then I will see. Okay, these are the figure 3. This is figure 3. This is vertical, and this is figure 2. This have some horizontal lines, and this is figure 1. This was the original image. Okay, and now what I have done at last, one command is commented. What I am doing, I am taking a square root of horizontal square plus vertical square. I am just mixing these two. Then this is useful. What is the use of that? This is called edge detection. So now this filtering is useful. So this is the standard filter that I have used here. The value is 1 to 1, 0 0 0, and -1 -2 -1. The value of this filter, this is called edge detection filter. The value of this filter is 1 to 1, 0 0 0, -1 -2 -1. So originally this works for horizontal edge detection. If it is used as it is, if you want to use it for vertical edge detection, then it should be transpose of this H dash. The transpose of this is called actually mirror image of this. Okay, so that is why, and then you can take the square root of both of these things. Then it will be useful for the edge detection. So that is what we can see the advantage of filter. You can see the effect of filter. Okay. Let us go back. You can do practice. You can write program for performing edge detection in the color images. You can transfer this concept to the color images, separate the RGB plane and apply to the RGB separately and see the edge detection of the color images. 2D correlation is similar to the little bit different, and just only we don't have to take the mirror image. All other things are similar. So in image processing, many times correlation is used, and many times convolution is used in this filtering process. So therefore, an edge problem, what will be the appending, is how the zero will be appended, because when this filter moves over the image, and when the filter moves, then if it reaches to the edge, near to the edge, then this may go out like this, like what it is shown here. So this may go out. Then what the MATLAB will do, or what the filter will do? So there are three ways that either you can ignore these things, either you can pad 0 to the image. You can consider those values 0, and third thing is that replicate the edge. This is useful. This is much more better. That whatever values was there near to this, in this whatever values were there in the image, the same values to be replicated here. So that way the filter will be able to work. Otherwise, it will show you the error. So therefore, we can say that how the zero padding works in there. So there was one question at the time when I was telling the signal processing filter. There was a question that how the zero padding works in the so that there are three ways to do the zero padding, or to avoid the edge problem. This problem comes usually in the image filters. Okay, so these are the three ways, and how to apply these three ways. So these are the commands in MATLAB that we can apply this filter to filter, then image, then shape. If you write same in the third command, then it is then it is the keeping the same as the previous one. This, and then if you write valid, if you write full, then there are the same zero padding. Valid, truncation of the image, and full is full. Full means complete, means repetition of the image. So that is the way we can test this the problem, hash problem, in by writing these commands. You will be able to see the difference in the output. Okay, and that the output coming through after these three commands is not same. Okay, so this is the idea about the filters. You can apply this IM filter command for image filtering without converting, because in convolution 2 command that I was using in previous example is not from the image processing toolbox. Therefore, we need to convert the image into double first, and then we can use. If you want to use the image filter itself, then you can directly use IM filter command. That is useful. That is, then you don't need to convert before applying the filter, because it is already in this filter command, it is inbuilt, so automatically it will be done. Okay, so there is this is the application. There are some special filters available in the MATLAB, like averaging filter, circular disk filter, Gaussian low pass filter, log filter, motion filter. And this motion filter helps us deblurring of the image. So I will show example of motion filter, then we will stop. And you can try, you can practice these things just by, I will share this handout, and you can practice these things by yourself. And I will show one example, just this one. I will read the cameraman.tif picture image, and I will use. I can show you. I will show I. Then I am applying the. I'm creating one special filter, motion filter. 20 horizontal movement and 45 angle movement, and then I am applying it into I, and I will show you that how does it looks like. After applying the filter, how this image looks. And so you can see by this, just apply, just see that my image filter. This is second program of filtering, so I will save it as 2. Okay, so there is line 2. There is some problem in this because I have just pasted, so this character was creating some problem. I don't know whether this is available or not. I think this should be small because MATLAB is case sensitive. So that was the problem. See this is the effect of this filter. What is the effect? That this was the original image, and I have applied one filter, and this is blurred. You will say that, sir, filter is to remove the blur, to remove the noise. But here it is applying the, yes, you can just do the opposite thing to remove the blur. We can remove the blur also by using this filter itself. Then there are different ways to do the deblurring. That either you can use the Wiener filter for removing blur, or there are many ways. And so this is one example that I had created one, taken one image, and then I had applied the Wiener deconvolution filter, to remove the blur. Okay, so just see this, and because we don't have time to write the program this time, and we are already at the time of already at the completion of this. So I'll just show you the process, how it is working. You can try the same thing in your MATLAB. Some of the things actually get changed. I think that is okay. And what's the problem? 940. Okay. See this one. This was the original. This is the deblurred image. This is the figure 2. This is figure 1. This is the blurred image, and this is the deblurred image by filter. Okay. So this is what I showed you in the starting, that we can remove the blur if blur is created because of the motion of the camera. So that can be removed with the help of filters. Okay. So we can use these special filters. These all are special filters. Average filter, this filter.
Sir, your audio is not coming. Hello. Hello, Atul sir. Maybe there's some connectivity issue. Dr. Atul will join soon. So if you have any query regarding today's session, please write in chat box so that we can be updated to those.
Okay, so there was some connection issue. Okay, that therefore that was disconnected. Anyway, so if you have any question till now, you can ask. Otherwise, we will end the session here itself. Okay. There is no question.
Yes, sir. One question is there.
Okay.
Sir, actually, image can be called as a matrix of rows and columns, na?
Yes.
So, is there any chance that we can differentiate that image into sub matrices and differentiate the image?
Okay. I think you are saying that how can we differentiate whether it is a matrix or whether it is an image? Okay.
No. I mean, image can be, we can cut out the image of small sub matrix. That's what I'm saying.
Yes. Yeah. Okay. Then.
I mean, is that possible in MATLAB?
I'm not. What do you want to say that you are you saying that can we cut? Yeah, can we crop the small parts of image into small matrices? That is,
Yes, sir.
definitely we can do. Definitely, because image is a matrix, and from any matrix you can separate sub matrices. So from image also you can make sub matrix.
And I mean, is there any block that can do itself, or you can have to just make the code for that?
You have to write code for that. There is no predefined function for that. But that coding is also not so difficult. You can write a simple code. Simple, suppose, for example, if I have A equal to, if I have saved image, and if the image is like this, 1, 2, 3, just I am giving example, 4, 5, 6, 7, 8, 9. So this is one image for me this time. Just a simple, just to give you understanding. Just I have a matrix which have values 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you want to separate some part of this. Okay, you want to create some sub matrix of this into another image B. So what will you write? What will you write? A, matrix A, second, how many rows? Second row to third row, and how many columns? Second column to third column, like this. So image have many rows and many columns. So in that case, you have to write 50, row number 50 to row number 100, row number column number 50 to column number 100, column number 100 to column number 200, like that, because there are hundreds of columns and rows and columns. For here in this AB, A image A was, currently I have changed, so this was 446 length. So like that, in hundreds it will come. But this time, for understanding, I am just writing B equal to A from row number 2 to row number 3 and column number 2 to column number 3. Your B is 5, 6, 8, 9. That is what I wanted. So one submatrix is created. So yeah, as you can create submatrix of a matrix, you can create sub part of an image. So for example, if I read this image this image, for example, if you have this one image was there, I will evaluate this selection. So image is there in A. Now, if I want to separate some part of this image, just a minute. Let me CLC and clear. So if I read an image A equal to, I am read this image I am reading. Okay, it have 284 rows, 353 columns. I will convert it into grayscale so that it will become a single matrix, because in color there are 3 matrices. I have converted into grayscale. I will show you how does it look. You can see. You can see that this is looking like this. This is the image. Okay. Closing it, so it will close. And now I will save a small part of this into C. How can I save? I have to write B, row number 100 to 200, column number, columns are also 353. So column 100 to 200. It will take some part of the image into C. Now let me write. I am so C. Let us see. See, this is a part of image. This is part of the sub part of the image. Are you able to get?
Yes, sir. Yes, sir. Yes, sir. Thank you.
This is what you are looking for.
Yes, sir.
Okay. If there is any other question, then we can stop here.
Yes, dear participants, if you have some queries, some questions, some confusions, or any other thing regarding today's session, you can ask here. Otherwise, we will move for the validity program for today. Okay, I hope we can move for validity program for today. Dr. Patel sir has joined here. Professor Rajkumar has also joined the session. Rajkumar sir, Dr. SSK sir will join.
Sir, yes, I have joined.
Yes, sir. Yes, sir. Good evening. Good evening to all of you, sir.
Good evening, sir. Panda sir. Good evening.
Good evening,
Good
sir.
evening, Sanjit sir.
Good
Here,
evening, sir.
Yes, sir. Good evening.
Good evening, Dr. Atul.
so here I welcome Dr. Aryan Patel, sir, Dr. Sanchil Kumar, sir, Professor Raj Kumar, sir, and all the participants here once again for this valedictory program on the completion of our module 3, that is signal and image processing. And for this session, I would like to invite Dr. Aryan Patel, sir, at first to address the participants present over here on the completion of this module 3. Yes. Aryan Patel.
Hello. Can you hear me now, sir?
Yes, sir, sure. Your audio is clear.
Yeah. So welcome all the participants to this last day of your module 3 of this workshop. I'm sure you have all had very good experience in learning MATLAB. I would just like to give few messages to you. Like first of all, that the more you actually practice, the more you learn. So basically, it's just like it's a software is just like any. It's just we call it language. It's okay. It's just a language. Just the way you speak a language, you learn more about that language. Same way, if you don't speak the language, you forget. The same thing is true about MATLAB. If you do not practice it, you'll forget. Therefore, the practice is very important. Practice makes a man perfect. So we have to always practice and never lose track of practice. So practice it. If you want to actually learn it, teach it, practice it, and also try to experiment new things. If you actually, I learned MATLAB the same way. Let me tell my own story about MATLAB. Basically, right from my school days, I was fond of computers. Although it was at that time it was 1990s, right? So that time I was doing my schooling. In fact, before that, so 19, right? So I used to have there was only one computer in my school, only single computer. It was first time it was purchased by school. In I think it was in somewhere in the year 1985 or yeah. So then I used to register book our slots in the register. This time at that time there was a teacher. Anyway, I don't want to make it a long story. That he came to tutor us for. Then I learned Fortran. Sorry, basic language, not Fortran. And there used to be course, and there used to be exam. So that actually gave me a habit of, then I used to think about this program. Even when I'm not having computer, I used to think about the programming, how to actually, practice it. How to, even I used to write in a paper, copy and paper, and then whenever I got time, I used to execute that. So I used to feel very happy when things worked out. So the idea is that then from that time, I started practicing basic, then Fortran, then C, C++. I learned, and I went to IIT Delhi. So the idea is that actually I learned without a teacher. That's what my whole story was about. I didn't have any teacher. I just kind of practice, struggle, and again practice. Same thing happened. So the first course which I did in my engineering was So it was when I was doing my engineering. It was Fortran. So before that I was just I didn't have a teacher for this thing. Just wanted to. There was some kind of classes going on, but Most of the time it was self-learning. Then MATLAB, when I started MATLAB in my research, it was actually completely self-learning because I had a sense of logic. Till the time I had learned in my master's program in IIT Delhi, I learned C++ also. So, MATLAB was self-learning, and it is till date, MATLAB is my own self-learning. And I wrote a book, you all know that, Pearson's book. It was also just, so there was no extra, tutor for MATLAB. So idea is that once you have programming logic in your head, you can translate it in any language. You don't need any actually, So the thing is that, of course, some things which I learned in MATLAB at that time, I started learning MATLAB in 1999, right? So when I was finishing my master's, when I finished, and then I went to a PhD program, then I learned MATLAB, started in 1999-2000. And likewise, so this is that time, it was been practicing. Whenever I got time, it was kind of a, passion. Just open MATLAB and see something new, experiment something new, learn, explore. Fortunately, MATLAB has very good help. So my message in this session to all of you is to use the help, use the documentation of MATLAB, use the support of MATLAB. I have made a short video. I think you all have that. On how to use the help and documentation. So that's what I suggest. Use the documentation, use the support, use the help, and you'll get to know many more things. It's not possible to cover everything in one workshop, but even today I am learning. In fact, whenever I take classes, I actually try to, before the class, I take half an hour and explore new examples and try to present it to you. So every time if you join, it will be something new because I innovate, and in fact I try to renew my knowledge, refresh. So this is a habit actually. It becomes a habit. Once you have this habit, you will learn everything fantastically, and you will actually, I used to even whenever somebody came to me, I used to say, if you have any difficulty in MATLAB, ask me. This is the way you can learn. If you teach, you learn. Okay. Even in fact. So many of my students now they are knowing better than me. I don't have problem saying that. So in fact, Dr. Atul also taught MATLAB when he was studying, but in his area he knows better than me. This is the way. So anybody can know better than us in any area, of course, because everybody's area is different. So once you start habit of exploring, sit on MATLAB and explore. Just go to the demos. Just go to the supports. There are many things. Just to list you. First thing is the MATLAB demos. Second one is MATLAB documentation. Third one is MATLAB webinar in the MathWorks website. And then fourth one is File Exchange. You'll find many programs in File Exchange also. So if you want to learn something topic, explore these webinars, File Exchange. That will give you continuous learning. There are many books on MATLAB. Keep practicing it. Keep looking at it, and in fact, take a problem, challenge. Take a challenge, and somebody brings challenge, you'll be happy. It is solved with MATLAB. So this is the way you can refine your knowledge of MATLAB continually, and that's what I say today. Last point from my side is that it's not only a research tool; it's a teaching tool. It's a virtual laboratory. Many things you can explore through MATLAB, and MATLAB has become a kind of one tool which covers everything that you need, including the hardware. So we have demonstrated some of the hardware interface also. In future with the Intelligent Tech Solutions, we'll also launch some hardware-based Python and Arduino and all those things. We want to launch it for your knowledge, and especially the Raspberry Pi and Arduino programming hardware through MATLAB. We'll cover that in future programs. So please wait for that. The next we are also starting this the optimization, right, in the next week. So that will be new tool, new domain. MATLAB has hundreds of domains, so you can explore whichever domain you want to, and in fact explore it. So whenever you need to do some research, guidance, teaching, use MATLAB widely in all those things, right? So that's what we have. Yeah, Madam Padmalata. Of course, that next week, Tuesday, I think we are starting this optimization. Of course, there are other experts also who will be, apart from us, who are experts in optimization, they'll also be speaking on that. So thank you, and thanks for inviting me to address. This is my words to all of you. I gave my own example. Practice makes a man perfect. Okay, and women too. So just joking. So right. So that's what we will. Yeah, Raspberry Pi will cover definitely. We're waiting for basics to be finished. Thank you, Panda sir, for inviting me, and thanks. Please feel free to contact us whenever you have any difficulty. We'll try to solve it, even after this course. Be connected to Google Classroom. Thank you. Yeah. Thanks from my side.
Thank you so much, Patel sir.
Thank you.
And it was a good address by you that how can we be continue with MATLAB. Per my experience also, I also learned like that. I just do have practice, and one by one we will learn new and new things. So furthermore, Diligent Tech Solutions and Elixir Education Services, we compiled a video of your certificates for the completion of this course, Module 3, that is Signal and Image Processing. I would like to present with the permission of Dr. SSK sir.
Yes, sir, you can proceed.
Yes, sir, sure.
I'm studying in Amritsar, Vishwavidyalayatam. I have enrolled and completed the course MATLAB Module 1 from Elixir Educational Services. Here, they will teach us through perfect planning, and even the beginners who don't even know anything will be experts after going through this course. Then they will give us a schedule regarding the course at the start of the course, in which within the first day we will be taught some theory sessions, and after the day they will give us the problem based on the previous theory session, and we have to solve those problems, and the doubts will be explained to you. Even the smallest doubts will be explained with utmost care, and they also will give us the reading material which is a Pearson book written by R. Patel sir. He was one of our teachers there, and I found this course pretty interesting. Thank you. The MATLAB course provided by Elixir Education Services was very good. Special mention to the faculties who drove us through the entire course from basics in a very effective way. I thank all the faculty who helped us in understanding the concept in a clear way.
Thanks to all of you. Thanks to Diligent Tech Solutions teams. And at this end, before inviting Dr. SSK sir, Dr. Senthil Kumar sir, I would like to invite the participants, if you want to share some thoughts about this module 3, that is signal and image processing. What about your thoughts? What about your values or important points? What you have noticed? What are the views you want to give for this module? I would like to invite you on. One by one, you can unmute yourself and you can speak something. Then I will invite you, Master. Yes, I think UP Brahma sir want to say something.
Yes, sir. Very good evening, and I felt very happy, and I'm feeling very joyous to meet you and listening you. I'm very much fortunate enough that I have got most of my problems which were due to be solved. It is the MATLAB which had helped me a lot. Uh, the signal processing, especially, and image processing, which was very much typical problem for me. I was really not knowing even ABC of image processing, how it is being done. But within these 15 days, I could learn a lot, but still I have to learn more, because it is, as you have said, and I too feel that it is a matter of practice. Since I have not got the software this time, otherwise I could have practiced it more and more. I am very much queer and very much inquisitive about learning all these things. So new things are there to explore. Really, it's fantastic. Really fantastic was the session. Thank you very much, sir. I would like one thing more. If you are giving us some of the opportunity to contact you, if we are having some of the problems in our research, and some of the like in image processing, signal processing, and some of the data calculations, etc. So would you be in our help, sir?
Yes, definitely.
Yes, sure.
Our team will help you.
Thank you, sir. Thank you very much. Thank you. Thanks a lot.
Thank you, Verma sir. Any other participant want to share some thoughts? Thank you, Padmalata madam, for sharing your thoughts. If any other participants want to share something, please unmute your mic and you can speak.
Vijay Saran, if you want to say something. Yeah, Parisha Begum, if you want to, if you can say in mic by just unmuting the mic, then it will be much more better than others can hear.
Actually, when you speak, it gives motivation and also maybe some feedback for the further improvement. Speaking is better if you can. Not long, but just 1 minute speak is enough.
Sir, good evening to all. This is Dr. Suresh from NIT Warangal.
Good evening, Suresh sir.
Yes,
happy to see you again.
Means, are you able to hear my voice?
Yeah, very well, very clear.
Yes, sir. Audible.
Happy
Sir,
to
thank you very much to Dr. Atul sir and your team. I mean, really, I learned a lot what I expected, because I learned more than what I expected. I mean, the total entire session I enjoyed a lot. I mean, actually, especially I entered the new field of image processing. I never did in my PhD as well as my MS. But here I learned a lot, and I mean, that way of engaged me, this team, really, I wished that. I mean, it was really enjoyed that. And the way of explanation, it's very excellent. I mean, because, I mean, even I didn't know early how the RGB is playing in the image processing, right? I mean, here I enjoyed, like, I mean, they engaged me in the simple manner, the RGB, how it's playing to form the matrix to filtering the image processing. Similar way, I engage, I mean, very interested in the signal processing. I mean, somewhat I know, but here I learned somewhat more in the signal processing. But anyway, sir, the total, I mean, entire session went well. I really enjoyed a lot. Thank you very much for your opportunity. Thank you, sir.
I think you are an avid learner. So you're learning all the things in a short time. It's nice to see you, Suresh sir. Yeah. Thank you.
Thank you for your active participation also. You had asked very nice and questions in the sessions. So I thank you also for asking nice questions.
Hello, sir. Am I audible?
Yes, you're audible.
Yes, sir. I am Ankul. I am a PG student from Walchand, Sangli. And I would like to thank you, Dr. Atul, sir, for this great session. They literally they literally pull us out from the combined confusion of the MATLAB, and that's a very great session. And I would like to thank again for the Atul sir and team.
Thanks, Uncle Kumar sir. Yes, so here we are at the ending of session. So before inviting Dr. Senthil Kumar sir, I would like to say that we are launching our module number 4, that is optimization in MATLAB and introduction to GUI, with the same 15 hours duration of course, starting from 20th of July, with eminent speakers outside from our team also, because they are best in their field, best in this topic. So I would like to request you all that participation, if you want to go for learning optimization or graphical user interface, you can join that that module also. So here at the ending of session, I would like to invite Dr. Senthil Kumar sir from Diligent Tech Solutions team to say vote of thanks for this module, for this valedictory program. Please.
Thank you,
To
sir.
share the last information, sir. I mean, really, I'd like to say thanks for the organizer. Without organizer, none of the events had happened, right? So really, they engaged all the participants in nice manner. That they have done in proper time and the proper updates. Really, thanks for your nice organization, sir. I mean,
Thank you, sir.
Thank you,
Thank you
sir.
so much.
Yes, sir. Thank you.
Yes, welcome, sir.
Okay, I'm going for vote of thanks. Good evening, my dear participants of hands-on online workshop on signal and image processing using MATLAB. It gives me immense pleasure to receive positive responses and proactive cooperation from the participants from the nook and corner of our India. This sort of workshops are really boon to all the research aspirants. We strongly believe that you had enjoyed the learning experience through this workshop. We wish you to reach all the heights to your life by updating the learning process consistently. At this juncture, I would like to thank my co-organizers, Dr. Tangaprakash, Professor Rajkumar Ramanujam, for their full-fledged cooperation. It gives me immense pleasure in thanking our resource persons, Dr. R.N. Patel, Dr. Atul Kumar Dwivedi, Dr. Lalit Kumar Sahu, Mr. Kamesh Rao, Ashish, Mr. Kavisadi Gopal Panta, and Yugal Kishore for their wonderful participation, wonderful resource. On behalf of Prime Academy, Elixir Education Services, and Diligent Tech Solutions, once again, I thank our participants for your wonderful participation and proactive cooperation. Thank you all.
Thank you. Thank you so much, Dr. Senthil Kumar sir. I once again thanks to Dr. Atul sir for giving such a knowledgeful course. Dr. Dr. R.N. Patel sir, and other participants also, some other speakers who joined the session in this between us. So once again, thanks to all of you for your interactive participation. I hope you will be connected with GCR, Google Classroom, since the GCR will be for longer time. So once again, thanks to all. Thanks for participation. Let's end up the session here.
Thank you all.
Thank you, sir.
Thank you, sir. Thanks, everyone, and wish you all the best for your future. Happy learning, and hope to see you soon. We'll try to provide you supports whenever you need. Please
Thank you,
keep in
sir.
touch. Thank you. Thank you. Thank you. Sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.
Yeah, thank you all. Thank you so much.